All right, I'm honored to introduce our final speaker, Dave Peck. Dave's an independent software developer who, among other things, writes about tech, music, and what Dave calls other nerdy topics on his blog. His blog mentions that he is currently experimenting with AI-flavored data pipelines, and he helped write the official Python documentation for t-strings, which is the subject of today's talk. Please join me in welcoming Dave Peck for his talk entitled Introducing T-Strings, F-Strings with Superpowers.
So hi everyone, and thanks Steve. I'm Dave. I'm an independent software developer based in never rainy Seattle. And since we're all here in the Pacific Northwest, Seattle is every bit never rainy as Vancouver is, as we all know. And so let's go ahead and talk about PEP 750, which is better known as template strings and perhaps best known as T-strings. So this 20-minute or so talk is just going to be a gentle tour. We're going to talk about what T-strings are, why T-strings are, how we might use them, and maybe we'll talk a little bit about the future. And along the way, in order to explain T-strings a little bit better, we're going to have to hit a few obvious touchstones. I don't think these need a lot of explanation, but we'll obviously have to talk about chess grandmaster Magnus Carlsen. He's been the world champion of chess for the last over a decade. And of course, we'll talk about Wayne Shorter, who unfortunately wasn't around for the release of Python 3.14 and T-strings, but I think would have been a heavy user. And then, of course, we'll talk a little bit about Girl Scout cookies. Now, if you live in Canada, these may not be super familiar, but if you've been south of the border in the last, 4 weeks, you've probably seen Girl Scout cookies on every street corner in every city in America. So what are T-strings? Well, they're a new feature that shipped in Python 3.14, and I like to think of them as like F-strings with superpowers. And they sort of have two different superpowers. One is that they help make F-strings safer, and the other is that they help make F-strings more flexible. And we'll talk about both of those in great detail. But first, I want to talk a little bit about the way that they are like F-strings. And probably the most important is that they share the same syntax as F-strings. So here's a bit of Python code that's been valid since F-strings shipped in Python 3.6. Probably looks pretty familiar. And if you watch that letter F really carefully, switch it to a T, and this is valid Python 3.14 code. It really is the same syntax, so even if you have a fancier F-string, say something that formats the price a particular way, F goes to T, and you've got a T-string, and that's completely valid code. There's one subtle way that F-strings and T-strings are the same, and because T-strings and templates, the word template is such an overloaded term in the world of computers, it's good to kind of remove your preconceived notions if you're coming from the world of Jinja, or if you're coming from the world of C++ and you have a notion of what a template is. Might be worth stepping back and thinking about it differently. So here's an example bit of code in Python 3.14. It's completely valid. It works completely fine. And if we comment out this first line of code, what we see is that both the F-string and the T-string raise a name error, because of course friend isn't defined. So both F-strings and T-strings have their expressions inside those curly braces evaluated at the same time, so eagerly. So T-strings, they're F-strings with superpowers. And the way I like to think of it is that F-strings are just plain strings. And what I mean by that is if you have this little bit of code right here, by the time the F-string gets to your code, the type of it is just plain str. It's like any other string in the world. You can't distinguish that it came as an F-string. And T-strings are, well, they're not strings. And I apologize, naming things is hard. You write them like they are. I guess this is my Magritte moment right here. This is not a string, so this is the T-string literal syntax in Python 3.14. But they evaluate to a new type, template, which in Python 3.14 you can find in string.templatelib.template. And the template type gives you and your code access to the parts of your string. And so it gives you access to the static parts, and it gives you access to the substituted parts, the parts in curly braces. But because we're highfalutin here in Python land, we like to call them the interpolated parts. So let's go ahead and take a look inside a template. So here's some valid Python 3.14 code that creates a template instance. And the easiest way to look at a template is just to iterate over it. And so I'm just going to go ahead and do that here. And you can see that what's inside a template is the static parts of the string, the high and the exclamation point, and this new type, interpolation, which represents a substitution in there. And I can reach into the interpolation and get the value world out the other side. There's some other ways that templates let you access their content. So you can access the static strings directly. So here's the 0th static string. And you can access the interpolations directly. And interpolation, by the way, is also a new type in string.templatelib in Python 3.14. And so it has this value hanging off of it, and that's how you get at the string world in this example. So what can you do with t-strings? Well, imagine I just took a job at a new company called Lower Upper Incorporated, and they don't do much, but their one business rule is that all static content needs to be lowercase, and all dynamic content needs to be uppercase. Now, probably what I ought to do is tender my resignation right away. I'm not sure why I applied for this job, but let's go ahead and give it a shot here. And so what I'm going to do is create a list of strings, regular strings, and we're going to iterate over our template. And every time we see a regular string in the template, we're going to lowercase it and add it to our list of parts. And every time we see an interpolation in the template, we're going to go ahead and grab its value, uppercase it, and add it to the list of parts. And then we're going to join those things together, and we have lowercase hello, capital world. And we survived our first day at Lower Upper Incorporated. Whew. All right, so this is a really silly example of what I call processing templates. And really, there isn't much complicated to think about here. Templates are normal Python objects, and you can write or call code to turn them into a string, or it's arbitrary Python code. You can turn them into any other type, and we'll take a look at some examples of that in a bit. But I do want to step back for a second and say, yes, but why? Why do we want these things? Why do we care? And so let's go ahead and talk about f-strings. And I guess the thing that's important to understand about f-strings is that they get used a lot. Since they shipped in Python 3.6, they've kind of taken the Python string formatting world by storm. And you can go to GitHub and search public repositories there, and it's just countless repositories that use f-strings. And I think that's because they rock. They're powerful, they're readable, they have this really elegant syntax that's easy to write. This is, I apologize, AI generated on the right, and don't look too closely at the neck of that base because it's horrific. But you can also search GitHub and find a lot of examples where people used f-strings to, say, write SQL or to write HTML. And if you look carefully enough, you can find lots of repositories where people inject untrusted content into their SQL or into their HTML. And so that leads to SQL injection vulnerabilities, cross-site scripting in HTML. Basically, f-strings are so great and so desirable that we use them instead of all the other libraries that we have out there. So I take it as a sign that Python could bring some new features to the fore, and that's what t-strings are for. So templates make strings safer. And the easy way that they do this is that they retain the structure of the string. So the template instance holds on to what is static and what is dynamic. And one way you can interpret static and dynamic if you're building a library for SQL or HTML is trusted and untrusted content. And so as a result, libraries that use t-strings can smartly escape values. So raise your hands if you've seen this XKCD before. This is sort of the quintessential XKCD. Little Bobby Tables. I gotta say this mom is really playing the long game here, naming her son that way. But this is a great example of a SQL injection vulnerability. And so I thought we'd write our own SQL injection vulnerability right here. So this is Little Bobby Tables. Basically, we have some hypothetical database library, and it's got an execute method, and we write a get student that takes the name of the student, and it executes this little bit of SQL. And when we call get student with John, everything is okay. This actually works just fine. But the moment Bobby Tables enrolls in our school, we've got a bit of a problem, and actually we drop the students table. But now with t-strings, if our hypothetical database library updates itself, they can add a new method, let's say execute underscore t. We can call that, and with just a small number of code changes, now Bobby Tables can't actually cause us any problems. And so that's just a real benefit of t-strings in the Python world. But they also make things more flexible. So let's talk about HTML for a second. So here I've got a hypothetical library with an HTML function that knows something about t-strings. And in this code, we're getting a user from the database, and we're rendering the user's name in a div. And so in the case of John, of course, that's going to be safe, and you probably could use an f-string to do this. Of course, if the user punched in their name with a script tag, well, then all bets are off. But the good news about this library is it's t-string aware and it's going to escape that invalid content. But of course, we don't have to return a string from HTML. We can return an element instead and actually return a tree of elements from whatever HTML you toss into that t-string. And then, of course, we're able to access the tag of the element in some structured way. And of course, if we want to render this to send it back to the browser, we can probably use the stir method. But there's a lot more we can do with this hypothetical HTML function. So here's an example where I include an attribute. And it might not be clear at first, but watch that line of code. We're going to add some quotes to it. And you can see that whether I include quotes or whether I don't include quotes, the result of stringifying that element is the same. So it's convenience. Here I've got a dictionary of attributes. So an ID and a list of classes, and this hypothetical HTML method is actually going to take that t-string and spread the attributes. So I get an ID attribute and I get a class attribute where we've concatenated user and active with a space in the middle. And this is sort of what I call fancy template processing. That theoretical HTML function has to do a lot. It has to parse the template. It has to examine each substitution in that template. It has to look at its type and its position in the underlying HTML grammar. And based on those things, it has to decide how to render each value. So I want to take a sidebar here and say, well, when do you use f-strings and when do you use t-strings? And if you're wondering, should I just stop using f-strings because t-strings have superpowers? The answer is no. Probably today in Python 3.14, you want f-strings like you always have. Nothing has changed about f-strings. They're just as valuable and useful as they were before. I think when t-strings become interesting is when you need escaping, when you have this notion of trusted and untrusted content. I think t-strings are also interesting when you have a grammar, and we'll talk a little bit more about that in a moment, but HTML being a good example, or SQL being a good example. And then I think most likely, use t-strings when your library does. And so I think what we'll see over time in the Python community is libraries starting to adopt these features so that the SQL library you use today may one day support t-strings, and that's probably going to be a time to start using them. Before I talk about libraries and grammars, I do want to go on a little side quest here. And that's going to take us to one of my favorite websites of recent memory. I think somebody in this room is somewhat responsible for it, for this delightful abomination. How many of you have actually taken the quiz at fstrings.wtf? Okay, a few of you. Well, it's a 25-question quiz about f-strings. And actually, it appeared right as we were wrapping up writing PEP 750. We kind of like locked down the specification. And I came in charged and feeling like I was going to just ace this thing. But no. No. Okay, so here's an example of a question on fstrings.wtf. Now, for those of you who would like to take the quiz and haven't yet, now is the time in this talk to cover your eyes, plug your ears. I don't want you to see the answer. I am going to reveal an answer to this. I'm not going to explain it, though. It is this bunch of nonsense right here, of course. And of course, fstrings.wtf has a bunch of other really delightful questions along the way. I definitely encourage checking it out. But one thing fstrings.wtf is really useful for is talking about the f-string parts of speech. So inside those curly braces in f-strings, you're probably used to writing an expression, a Python expression like any other. But you may or may not have seen these exclamation point A, R, and S's before, and all they are in f-strings is the equivalent of calling the ASCII repr and stir built-ins. So if you've never seen these before, no surprise, they're kind of uncommon in practice. But it's important to understand that because f-strings and t-strings share the same syntax, they can appear in t-strings too. And actually, you can get access to them. So here, if I look at the 0th interpolation and ask for the conversion, it's the character R. Probably the more interesting part of speech in f-strings is the stuff after the colon. They're called format specs, and you're probably used to them if you've used f-strings even a little bit. So here's an example of using an f-string to approximate pi to 2 decimal places. And really what's happening under the hood here with f-strings is effectively the format built in is getting called with pi and the string .2f. That's the same thing. It'll get you 3.14. And if you're wondering how the format built-in works, well, you can kind of go down, and the answer in Python, when you go down far enough, is, of course, dunder methods for everything. So this is pi.dunderformat.2f. And, you know, not to belabor the point, but another way to write this might be float.dunderformat pi.2f. So all the same thing. So this, here's a question I hoped had made it into fstrings.wtf. And what the heck does this fstring do? And you might look at it and squint and say, that doesn't seem right, and you'd be right. This is going to raise a type error, and that's because the dunder format on none-type, which is actually the default object formatter in Python, doesn't support any format strings at all. So the only thing it accepts is an empty string. So this will raise a type error. So I guess we need to start a new tstrings.wtf. Here's that f string again that raises a type error. So here's a question. What does the t-string do? And the answer is, this is actually A-OK with t-strings. This is totally fine in Python 3.14. It won't raise a type error. And actually, you can take the t-string and look on the interpolations and grab the value. Totally fine. And you can also grab the format spec, the string burrito. So why do we want that? Well, this is actually an intentional design decision. And that's code that processes t-strings gets to decide what things mean, what the format spec and what the conversion means. With f-strings, the format built-in is called automatically. With t-strings, it's not. So your t-string processing code can decide to call format if it wants to, or it can go crazy and do literally whatever it wants, and we'll see an example of that in a moment. All right, so back to reality. Grammars and libraries. And this gets us right back to Magnus Carlsen. Again, he's the reigning chess world champion. He's the chess grandmaster, has been world champion, I think, for over a decade. And one of the tiny little grammars that I think is really interesting in the world is chess notation. Now, I should say, there isn't just one chess notation out there in the world. There are many. And so we're just going to take a quick look at one of them. But here is a board from a Magnus Carlsen game where it was a mid-game, it was a blitz game, and he was just utterly dominating. And you can imagine a little bit of code here that grabs the knight from the board. It's the piece at d5 that's highlighted over there. And then we're going to target that pawn over there. Because when we target that pawn, not only are we going to put that king in check, we're actually also going to be able to fork and attack the queen if we want. So it's an amazingly powerful move here. And normally this would be written in chess notation documenting the history of a chess game as knight x f6 plus. The x means that the knight is going to take a piece, and the plus means that the knight is also going to put the opponent in check. And this is a grammar that's developed over 100 years of playing this game. So here we're going to put it into a t-string. So we're going to take the knight, and we're going to take the target, and we're going to dump them into a t-string. And if we used an f-string here, obviously knight would have to be formatted, it'd have to be stringified, and so would target. But since we're keeping this stuff inside a t-string, presumably the code we write to process it can look at these rich types, whatever type knight is, like a piece, and whatever type target is, like a square. And so we can actually go ahead and call board.apply this move. And presumably board.apply takes a look at the move and makes sure it makes sense. So if we didn't include the x, or if we didn't include the plus, presumably it would reject it. So what about Wayne Shorter? Well, I don't even know where to start talking about Wayne Shorter. So he was in his early 20s. He joined the Jazz Messengers, Art Blakey's Jazz Messengers, and quickly became their de facto composer. And then about 5 years after that, he got sucked into Miles Davis's Second Great Quintet and basically wrote the book on jazz of that era. And then in the early 1970s, Shorter and Jaco Pastorius, who's a really famous jazz bass player, and Joe Zawinul, who's a keyboardist, formed a band called The Weather Report. And the way I like to think of it is it took three towering geniuses of jazz to invent elevator music. And so music notation kind of comes up as something that has a grammar too. So this is an early piece of Wayne Shorter's called Speak No Evil, which I think is really interesting. He wrote it in his 20s, and it already shows some of the weird, like, space alien harmonic development that his music has. So here we can imagine a library that lets us represent chords and uses t-strings to represent something about the structure of the music. So here we've got section A written out as alternating C minor and D flat majors. Now you might say, hey, wait a second, I don't know that I really need to use a t-string for this. Maybe I could just use a list. But I think that pipe character in between each of these is saying something more than just one chord after another. It's saying that we're at the end of a bar. And so in a way, it's part of a small grammar. And if you look at the sheet music on the right, well, you can see lots of expressive notation that you could imagine could fit in a formal grammar inside that t-string in just a few bits of characters. So I think this is a place where it might be interesting to think about t-strings. And of course, once we have that, we can transpose up to semitones, or maybe try and do Roman numeral analysis, which, by the way, if you do with Wayne Shorter's music, will drive you mad. And then here we could actually use format specs to say, hey, I would like to voice the tonic with a drop 2, and I would like to voice the sub with the upper. And so we get some voicings out the other side. Another place you might want to think about grammars is knitting. I'm not a knitter, but I did see somebody making a sweater earlier in this conference, and it really called to mind that knitting patterns are themselves a grammar. And then, of course, libraries. So t-string libraries. So earlier in this talk, we had an example of importing from some library. Actually, that library exists today, and it's called tdom, and you can go and grab it on PyPy right now. It's an HTML templating library that's built on t-strings. It's open source. And if you've used JSX and live in that world, or if you've used lit HTML, I think it'll feel familiar. That's the intent. It's marked, by the way, as pre-alpha for very good reasons on PyPy right now. It's subject to a lot of change, so expect an adventure if you do decide to adopt it. And that brings us right back to cookies. These are the 2 peanut butter varieties of Girl Scout cookies. The chocolate-covered one's called a tag-along, and the other one's called a do-si-do. Do-si-dos sell terribly. They're like 2 or 3% of all sales. They're the best. They are the best Girl Scout cookie. And this is what Girl Scout cookies look like on the administrative side. This is a piece of software called eBuddy, which I hope for your sake you will never have to use. It's actually a piece of software that's written by the bakery, Little Brownie Bakers, that makes these cookies. And it's an accounting piece of software. So this is where troops actually have to enter in their sales information. And unlike normal accounting software for retail, eBuddy doesn't even contemplate the possibility that when you have 3rd, 4th, and 5th graders selling cookies on the street corner, you might lose a box here or there or misplace it. eBuddy thinks of cookies as gold bullion. There's no concept of shrinkage here, which is kind of an amusing thing. This is one of the simpler screens I could find, and I chose it because it looks simple, but actually if you try and tab in order between these entry points, you'll find that the tab order is entirely nonsensical, so you have to pay incredible attention to every number you enter in. But thankfully, eBuddy has a bunch of reports that it can give you. And so my Girl Scout troop, which is the largest Girl Scout troop west of the Mississippi this year, we think, actually built a piece of software to help us manage 50 families. The typical Girl Scout troop is 6 or 7 families, selling cookies all over the course of 3 weeks. And so this is Cookie Trails. It's a piece of software that lets families manage their booths and figure out how many boxes of each type of cookie to bring. Thin Mints are by far the best sellers. Samoa's kind of in a distant second. This is what it actually looks like when you write down stuff at a booth. If you're lucky and things aren't chaotic, maybe you can keep good track of how many cookies you've actually sold. And then afterwards, the families can actually go and file a booth report. This is an unusually good booth. In 2 hours, these 3 scouts sold 431 boxes of Girl Scout cookies, about $2,600 worth of Girl Scout cookies. I can see up there that they're at the Kappa Delta House, which is a sorority in the University of Washington. So probably, I think the notes down at the bottom say total sunshine and college kid chaos. I think that's pretty much covers it. And then the treasurer of our troop can actually sit back and validate that the numbers make sense, the amount of cash, the number of digital sales, et cetera. So we have some reconciliation tools inside eBuddy, or inside Cookie Trails. So Cookie Trails is a Django application. It's just a CRUD application like any other, nothing particularly interesting there. Uses HTMX, which has really taken the world by storm lately, HTMX and Datastar maybe. And the big punchline is that it uses tdom for templating. So no Django templates whatsoever. And if you think about it, nope, just Python. There's some real advantages there. So I can, here's a bit of Django template code. This loads some tags or some filters. And if you think about it, that's really the Python equivalent of import some tags, except import is much more familiar, and we have vastly more tools and better tools to deal with that. Here's an include in a Django template. But I see that as a function call. And here, the function is actually typed correctly, whereas in the Django template, who knows what happens if you forget to include foo or if bar is the wrong type. In fact, calling components is so important and so common if you've used JSX that we actually have a special syntax in tdom to help you with this. So here's an example of using the greeting component, which is just a Python function, and kind of using this special syntax here inside the HTML call, inside the t-string. So basically use callable syntax to invoke it. And then you can actually use data classes as components too. So it takes its children, a title and a subtitle. It's kind of a visual card on the page. And here's its call that actually returns some HTML. And then here's the invocation of that. And that results in this HTML. And so you can imagine building a fairly sophisticated app like Cookie Trails with some hopefully nice family-facing user interfaces using this. And I guess the last thing I'd say is right now, tdom is a bit like I think this is a Model T here, but obviously some people have done some work on it. And so under the hood, we have a PR where tdom is actually compiling templates and caching the results of that compilation. And the result, even though the work isn't complete yet, so I don't promise too much, is that it's fast. It is much faster than Django templates. It still hasn't caught up to Jinja 2 because Jinja 2 really works magic under the hood. But we'll get there. And the last thing I want to say is it's not all roses using tdom today to build something like Cookie Trails. And in particular, formatting that HTML inside t-strings, inside your Python code is kind of a drag right now. So tools are coming. Tools for formatting, first and foremost, are, I think, the most important thing to make this like a usable developer experience. Tools for syntax highlighting, because it's always nice to see the parts of speech, even if you're writing HTML. And tools for type checking. This one's a little crazy. If you think about it, that HTML t-string, you've got Python types, and you've got substitutions in an HTML grammar. And you're saying something about these Python types are allowed at this portion of the grammar. So I'd say we're not super far along figuring out exactly what the best approach to type checking is. But we've got some nascent tools there, too. All right, so in the last 2 minutes of this, I just want to step back. You know, we spent the last 20 minutes talking about t-strings, which are this delightful little feature that shipped in Python 3.14. And I do find them delightful, but I also find them very little. They are the tiniest drop in the bucket of an immense number of features that shipped in Python 3.14. Really deep features like deferred evaluation of annotations, like syntax highlighting in the REPL, like all the work on the JIT and subinterpreters and free threading. Just immense amount of very sophisticated engineering work that's happening there. And of course, 3.14 is sort of a bucket in the ocean of amazing features that has found itself into the world in the last 30 years of Python's existence. But sometimes I really do like getting down to those atomic details and thinking about, okay, t-strings might be a bit of a trapdoor into writing better HTML, to building better web services with Python, to doing SQL better, to doing music better, or knitting. I don't know, and I'm excited to find out where they go next. So thanks.